Day 729 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 788, rotated digits. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. An integer x is good if after rotating each digit individually by 180 degrees, we get a valid number that is different from x. Each digit must be rotated. We cannot choose to leave it alone. A number is valid if each digit remains a digit after the rotation. For example, 0, 1, and 8 rotate to themselves. 2 and 5 rotate to each other, and in this case, they are rotated in different directions. In other words, 2 or 5 gets mirrored. 6 and 9 rotate to each other, and the rest of the numbers do not rotate any other number and become invalid. Given an integer n, return the number of good integers in the range between 1 and n. All right, y'all, so let's go ahead and take a look at these examples before we get into the solution. So in example 1, we have our input n equals 10, the output is 4. That means there were 4 good numbers, right? And our range is from 1 to n, which in this case is 10. So the explanation says there are 4 good numbers in the range 1 to 10, 2, 5, 6, and 9. So then it says, note that 1 and 10 are not good numbers since they remain unchanged after rotation. Boom. So let's break this down one step further. So in this range between 1 and 10, we have these good numbers right here, right? Because if we rotate this 2, we could flip it and it would turn into a 5. And likewise with this 5, if we rotate it and flip it, it could turn into a 2. If we rotate this 6, it could turn into a 9. If we rotate this 9, it could turn into a 6. Those are all the good digits in the range between 1 and 10. There are 4 of them. So that's why the output is 4. Then it says, note that 1 and 0 are not good numbers since they remain unchanged after rotation. So if we rotate 1, it's still going to be a 1. And then remember, we're rotating digits. So then this 10, we would rotate digit by digit, not the whole 10. So if we rotate this 1, it'd still be a 1. And if we rotate this 0, it'd still be a 0. So that's why they are not good numbers since they remain unchanged after rotation. Boom. Now let's take a look at example 2. In example 2, n equals 1. The output is 0 because it remains unchanged. They just told us in this explanation 1 is not a good number, right? So boom, if n is 1 and the range is from 1 to 1, that means, and 1 is not a good number, that means there are 0 good numbers. Boom. Then in example 3, we have n equals 2. The output is 1. There's only one good number in the range between 1 and 2, and that's 2 because if we flip 2, we could turn it into a 5. So since that's the only good number, we return 1, y'all. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we're going to get the temporary variable. We're going to create a temporary variable to process each number digit by digit. So we're going to declare, hold on. We are going to declare a variable called num, set that equal to 0. Then we need a variable to count the good numbers. So we'll declare a variable called count, and we'll set that equal to 0 to start as well. Then we're going to iterate through all numbers from 1 to n. So we're going to say for I n 1 ... n. We're going to open up the brackets and we're going to track whether the number becomes a different valid number after rotation by using a flag. So we're going to say if, or not if, we're going to declare a variable called is valid. We're going to set that equal to false to start. Then we're going to process each digit of the number. So we're going to say while num is greater than 0, we'll open up the brackets and we need to extract the last digit by saying let k equal num mod 10. Boom. Then digits that make the number invalid after rotation, 3, 4, and 7, do not map to any kind of valid digit. So we're going to come underneath this, and we're going to say if k equals 3, or two vertical lines, k equals 4, or two more vertical lines, k equals 7, then we're going to open up the brackets. We're going to set is valid to false, and we're going to break. Then the digits that change to a different number after rotation, we're going to, if we see at least one of them, then the number is good. So we'll come underneath this if, and we're going to say if k equals 2, or two vertical lines, k equals 5, or two vertical lines, k equals 6, or two more vertical lines, k equals 9. Then we open up the brackets and we'll set is valid. Sorry, y'all. Is valid. Set that equal to true. Boom. Then we need to remove the last digit and continue checking. So we're going to come underneath this. We're going to say num equals num divided by 10. Boom. And if the number is valid and changes after rotation, we're going to count it. So we'll come underneath this and we'll say if is valid, open up the brackets, we'll increment count by saying count plus equals 1. Then we need to return the total count of good rotated numbers by coming down here, and we just need to say return count, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly. Oh, we got the wrong answer. So if we got the wrong answer, 9 times out of 10, that means that the math is not mathing. So let's go over this math real quick. Let me see what's going on here. Okay. Let me see what's going on. Oh, sorry, y'all. We need to set nums to I first. So come up here and we're going to say num equals I. Boom. Now let's give this a run. See if that did the trick. And it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.